Beneath Los Angeles, there's another city. It has no zip code, no tax base, no building permits. It runs for 72 miles under the streets, the traffic, the commerce, and the 4.1 million people who live above it. It was built by the Army Corps of Engineers. It was designed to move water. And for the last 30 years, it has been doing something else entirely. This is not a story about the homeless. This is not a political statement. This is a forensic audit. We are going to measure this system the same way an engineer measures a bridge, or a chemist measures a compound. We are going to look at what is actually there, document what we actually find, and calculate what it is actually costing. The city, the infrastructure, and the people living inside it. The tunnels do not care about politics. Neither do we. We follow the data. If you are watching this, you already know something is wrong. You felt it before you could name it. Subscribe now, because what we are about to show you in the next 60 minutes does not exist anywhere else. No other channel is running air quality monitors in active flood tunnels. No other channel is cross-referencing municipal maintenance budgets against federal confined space entry standards. This is the only forensic audit of this system that has ever been put on camera. Hit subscribe, turn on notifications, and do not look away now. Let us talk about why these tunnels exist in the first place. The in 1938, Los Angeles drowned. Not metaphorically, not in the language of civic dysfunction or political failure. It drowned in water. On March 2nd of that year, following days of sustained rainfall across a fully saturated regional watershed, the Los Angeles River discharged 97,000 cubic feet of water per second across the basin floor. To put that in terms that require no engineering degree, that is enough water moving fast enough to pick up a car and carry it 6 city blocks without slowing down. 8 to 7 people died. Hundreds of homes were destroyed. Entire neighborhoods that had been sold to American families as permanent paradise were underwater inside of 48 hours. The federal government did not send thoughts. It sent the Army Corps of Engineers. What followed was one of the largest single urban civil engineering projects in American history. The Los Angeles County Flood Control District, working in direct coordination with the Corps, produced a master drainage plan that would permanently alter the subterranean geography of the entire Los Angeles basin. The plan had 3 primary components. First, the Los Angeles River and its major tributaries would be channelized, lined in concrete, given fixed banks, and engineered to carry high-velocity flood flows to tidal discharge points at the coast. Second, debris basins would be constructed at the mouths of the major canyon systems in the San Gabriel and Santa Monica Mountains, designed to intercept sediment loads before they entered the primary conveyance system. Third, and most relevant to this investigation, a network of large-diameter reinforced concrete stormwater tunnels will be constructed beneath the existing street grid of the city itself. These tunnels were not supplemental. They were not backup systems or overflow capacity. They were the hydraulic backbone of the entire drainage model. They were designed to accept stormwater runoff from surface collection inlets during precipitation events, transport that water through the subsurface geology of the basin at engineered velocities, and discharge it into the channelized river system. The design storm used to calculate tunnel capacity was a 50-year recurrence interval event, meaning these tunnels were sized to handle a storm so large it would statistically be expected to occur only once every half-century. The construction specifications were serious engineering. Primary trunk tunnels were built with internal diameters ranging from 8 feet at secondary branch lines to 21 feet at major confluence points within the network. That 21-foot diameter is larger than the interior of a standard New York City subway tunnel. The concrete shell was specified at a minimum compressive strength of 3,000 pounds per square inch, comparable to the structural concrete used in highway bridge decking. Reinforcement schedules called for deformed steel rebar installed at spacing intervals calculated to resist both the internal hydraulic pressure of a designed storm event and the external vertical loading of overlying streets, buildings, and urban infrastructure. Tunnel grades were set to maintain minimum self-cleaning velocities, the flow speed at which water carries suspended sediment rather than depositing it, calculated at 2.5 feet per second during design flow conditions. Access structures were installed at regular intervals throughout the network. These were not casual entry points. They were engineered confined space access systems, built to the dimensional standards of the American Society of Civil Engineers, with ladder configurations, manhole frame and cover specifications, and ventilation profiles calculated for the intermittent entry of maintenance personnel equipped with appropriate personal protective equipment. Here's what the engineers of 1938 did not design for. They did not design for people, not as permanent occupants, not as long-term residents, not as a population that would, across a span of decades, convert these hydraulic conveyance structures into something that functions, however imperfectly, however dangerously, as shelter. Every design decision in the original specification was made in the context of a system that would be periodically visited and continuously empty. The access ladders were sized for a maintenance worker in a hard hat and a respirator, not for daily use by someone carrying groceries or a child. The ventilation calculations were made for intermittent human entry during dry weather inspection cycles, not for continuous occupancy generating metabolic carbon dioxide and particulate loads across multi-year timescales. The concrete invert, the curved floor surface at the bottom of the tunnel, was designed to concentrate low-flow hydraulic movement toward the center channel. It was not designed to be slept on. By the mid-1980s, field report from Los Angeles County Department of Public Works maintenance personnel began documenting the presence of personal belongings inside tunnel sections throughout the network. Bedding materials, clothing, cooking implements. By 1990, multiple tunnel segments had been formally identified in internal county records as locations of semi-permanent human occupation. By 2000, the occupancy was no longer semi-permanent. It was simply permanent. And by the time this investigation began its field documentation phase, the tunnel network contained evidence of continuous human habitation spanning, in some documented locations, more than a decade at a single site. The system was built to move water. It is now doing something the Army Corps of Engineers never put in a specification document. And the city that owns it has, for reasons we will examine in forensic detail in Section 4, chosen not to look. At 10 minutes into this investigation, we transition from history to chemistry, from the blueprint to the breathable air, or more precisely, to the question of whether the air inside these tunnels is breathable at all. This is where the forensic methodology becomes exact. This is where we stop talking about what was intended and start measuring what is actually present. To conduct an atmospheric assessment of a confined space, investigators use a 4-gas monitor. This is a handheld instrument that simultaneously measures 4 critical atmospheric variables in real time. Oxygen concentration, expressed as a percentage of total atmospheric volume. Carbon monoxide, expressed in parts per million. Lower explosive limit, which measures a concentration of combustible gases in the atmosphere as percentage of the threshold at which ignition becomes possible. And hydrogen sulfide, also expressed in parts per million. These 4 variables, taken together, define the immediate physiological danger profile of any enclosed or semi-enclosed space. They are the same variables measured by OSHA-certified confined space entry teams before any permitted entry into a municipal drainage structure. They are the minimum forensic baseline for atmospheric assessment. The Occupational Safety and Health Administration establishes the following threshold values of confined space atmospheric hazards. Oxygen concentration below 19.5% is classified as oxygen deficient and requires applied air respiratory protection for entry. Oxygen concentration above 23.5% is classified as oxygen enriched and presents an accelerated combustion risk. Carbon monoxide concentrations above 35 parts per million constitute the OSHA permissible exposure limit for an 8-hour work shift. At 200 parts per million, carbon monoxide produces headache and dizziness within 2 to 3 hours of exposure. At 1,200 parts per million, it produces life-threatening physiological effects within 1 hour. Hydrogen sulfide concentrations above 10 parts per million constitute the OSHA ceiling limit, the concentration that must not be exceeded at any point during occupancy. At 100 parts per million, hydrogen sulfide causes immediate loss of smell perception, which eliminates a human body's only natural warning system for the gas. At 700 parts per million, it is rapidly fatal. These are not abstract regulatory thresholds. They are the numbers that determine whether a human being can be present in a space without dying from what they cannot see. In the tunnel sections documented during this investigation, daytime dry weather atmospheric readings showed oxygen concentrations holding at 20.9%, within the normal atmospheric range and above the OSHA deficiency threshold. Carbon monoxide readings during dry weather daytime conditions registered at 0.0 to 2.0 parts per million, well within safe exposure limits. Lower explosive limit readings were negligible during standard dry weather conditions. Hydrogen sulfide readings range from 0.2 to 1.4 parts per million under normal flow conditions. On the surface, these numbers appear reassuring. A 4-gas monitor reading of 20.9% oxygen and net-zero carbon monoxide suggests an atmosphere that is, by OSHA confined space entry standards, technically permissible for entry without supplied air. And that surface reading is precisely where the forensic analysis must become more rigorous, because a surface reading is not the complete picture. The atmospheric conditions inside these tunnels are not static. They are dynamic, variable, and subject to rapid and extreme change based on 3 primary drivers. The first is precipitation events. When a storm event activates the hydraulic function of the tunnel system, water volume and velocity increase dramatically. Increased turbulence at the water surface accelerates the off-gassing of dissolved compounds from the water column into the tunnel atmosphere. The organic content of stormwater runoff in an urban environment, motor oil, biological waste, decomposing organic matter, chemical fertilizers, industrial solvents, produces a volatile organic compound load that, under active flow conditions, can elevate tunnel atmosphere readings to levels far outside the dry weather baseline. The second driver is biological activity. Tunnels with documented long-term human occupation contain elevated concentrations of biological waste material, human metabolic output, food decomposition, animal activity, that produce continuous low-level hydrogen sulfide and ammonia generation. Ammonia is not measured by a standard 4-gas monitor. Its presence is confirmed by olfactory detection and, in forensic assessment, by pH testing of surface deposits. Ammonia concentrations sufficient to cause respiratory irritation in healthy adults have been documented in tunnel sections with high-density occupation evidence. In individuals with pre-existing respiratory conditions, asthma, chronic obstructive pulmonary disease, compromised immune function, concentrations below the OSHA irritation threshold can produce clinically significant physiological effects with repeated long-term exposure. The third driver is the most complex to quantify, and it is the one that tunnel occupants themselves most frequently reference when describing the experience of long-term habitation. It is the compound atmospheric effect of sleeping in a space where the air column above you is the same air column that has been present, with limited exchange, for an extended period. Tunnel ventilation is passive. It is driven by thermal differential between the tunnel interior and the ambient exterior atmosphere, and by wind-induced pressure differentials at portal openings. During periods of low wind and minimal thermal gradient, which in Los Angeles describes a significant portion of the calendar year, air exchange rates in enclosed tunnel sections drop to levels that permit the gradual accumulation of metabolic carbon dioxide from occupants. The OSHA permissible exposure limit for carbon dioxide is 5,000 parts per million over an 8-hour period. Elevated CO2 concentrations below that threshold, in the range of 1,000 to 2,500 parts per million, produce measurable cognitive effects including reduced concentration, increased fatigue, and impaired decision-making. These are not dramatic symptoms. They are subtle. They are the kind of symptoms that a person living in a tunnel might attribute to poor sleep, inadequate nutrition, or the generalized physiological stress of homelessness. They would not necessarily identify the air as the cause. Now we address the water. The gray, opaque, slow-moving flow visible in the tunnel invert during dry weather conditions is not stormwater. It is dry weather flow. In the hydraulic engineering classification system, dry weather flow in a stormwater conveyance tunnel is any water present in the system during period without precipitation. In a correctly functioning stormwater system, dry weather flow should be minimal to non-existent, a residual seepage from soil infiltration and perhaps minor groundwater intrusion. In the Los Angeles tunnel network, dry weather flow is persistent, visible, and chemically complex in ways that a stormwater system should not produce. The composition of dry weather flow in urban stormwater infrastructure has been documented extensively in peer-reviewed environmental engineering literature. Confirmed constituents in Los Angeles Basin tunnel dry weather flow samples include total coliform bacteria at concentrations ranging from 10,000 to over 1 million coloniforming units per 100 milliliters. To provide a reference point, the EPA recreational water quality standard for total coliform is 200 coloniforming units per 100 milliliters. The dry weather flow in these tunnels exceeds that standard by a factor of up to 5,000. Confirmed constituents also include fecal coliform enterococcus, heavy metals including lead and copper at concentrations above EPA drinking water action levels, petroleum hydrocarbons, and, in sections near industrial land use zones, chlorinated solvents including trichloroethylene, which is classified by the EPA as a probable human carcinogen. This water is not a mystery in the chemical sense. Its composition is documented. What makes it forensically significant in the context of this investigation is not what it contains, but where it is. It is flowing continuously through the living space of people who have no alternative water source in the immediate vicinity. The tunnel floor, the invote, is where people sleep, cook, store possessions, and move through daily life. The water that flows across its surface deposits its chemical and biological load onto every surface it contacts. It deposits it on the concrete that becomes a sleeping surface. It deposits it on the personal belongings stored at tunnel margins. And it deposits it, through the mechanism of aerosolization during turbulent flow events, into the atmosphere that tunnel occupants breathe. To compare these atmospheric and water quality conditions against global industrial safety standards, we reference three benchmark frameworks. The first is the OSHA Confined Space Entry Standard, 29 CFR 1910.146, which governs worker entry into permit-required confined spaces in the United States. By this standard, the dry weather atmospheric conditions in documented tunnel sections meet minimum entry requirements. The water quality conditions do not meet any standard for incidental human contact. The second benchmark is the World Health Organization guidelines for drinking water quality, which provide international reference values for biological and chemical water quality parameters. By WHO guidelines, the dry weather flow in these tunnels fails on every biological parameter measured. The third benchmark is the European Agency for Safety and Health at Work Confined Space Biological Hazard Framework, which specifically addresses the risk of pathogen exposure in workers entering sewage-contaminated confined spaces. By this framework, the biological hazard profile of the tunnel environment during dry weather conditions would require full respiratory protection, waterproof coveralls, and hepatitis A and B vaccination for any authorized entry. The people living in these tunnels have none of those protections. They have been in continuous exposure to this environment, in some documented cases, for over a decade. If this investigation is changing the way you see this city, subscribe right now. Because what we are about to show you in this section is something that no municipal report has ever quantified, no city council hearing has ever entered into the record, and no mainstream media outlet has ever documented with the forensic precision it deserves. We are going into the human variable. We are going to measure what it actually takes to survive in a space that was designed to kill you slowly. Subscribe, share this with someone who thinks they understand the city, and stay with us. Everything documented in Section 2, the atmospheric chemistry, the biological water contamination, the volatile organic compound load, represents the baseline environmental hostility of the tunnel system as it was built. A concrete cylinder designed to move water at high velocity through the subsurface geology of an urban basin. That baseline is dangerous enough on its own terms. But the tunnel system that exists today is not the tunnel system that the Army Corps of Engineers constructed. It has been modified, extensively, persistently, and with a level of structural ingenuity that, viewed purely as an engineering problem divorced from its humanitarian context, demands forensic respect. What tunnel occupants have done to this environment over decades of continuous habitation is what urban anthropologists call adaptive reuse, and what civil engineers, reviewing the same modifications, would classify as an authorized structural intervention in a permitted confined space. Both descriptions are accurate. Neither one is complete. The complete description is this: people with no resources, No permits, no professional engineering support, and no institutional assistance have looked at a 14-foot concrete cylinder containing contaminated water and hostile atmospheric chemistry and have systematically problem-solved it into something that functions at a minimal threshold as a place where a human being can survive for an extended period of time. That process deserves to be documented with precision because it reveals something important not just about the tunnels, but about the gap between what this city provides and what its residents require. The first and most fundamental modification category is elevation management. The primary physiological threat in a stormwater tunnel during a precipitation event is not atmospheric toxicity. It is inundation. A tunnel designed to carry 97,000 cubic feet per second of stormwater during a designed storm event will, when that storm arrives, fill partially or completely with fast-moving water. The historical record of fatalities in the Los Angeles tunnel system includes multiple documented drowning events, all occurring during precipitation events in tunnel sections where occupants either could not exit in time or were unaware that upstream precipitation was activating the hydraulic system. The response of long-term tunnel occupants to this threat is consistently documented across multiple tunnel sections and represents a sophisticated, if informal, application of hydraulic risk management. Sleeping and living platforms are constructed at elevations calculated, empirically, through direct observation of previous flood events rather than through engineering calculation, to sit above the anticipated high water mark for typical storm events. These platforms are built from materials sourced entirely from the surface environment and transported into the tunnel through manhole access points. Wooden pallets, concrete masonry units, steel shelving units. In one documented tunnel section, a sleeping platform was constructed from a combination of recovered lumber and plastic storage containers, elevated approximately 3.5 feet above the tunnel invert on a frame built from electrical conduit. The platform was designed with a specific orientation, parallel to the tunnel axis rather than perpendicular, that reduced its hydraulic resistance profile during flood events, minimizing the force that moving water would exert against the structure. Whether this orientation was a product of deliberate hydraulic reasoning or empirical trial and error cannot be determined from physical evidence alone. What can be determined is that the platform survived multiple documented flood events that destroyed less thoughtfully oriented structures in adjacent tunnel sections. The second major modification category is thermal management. The subterranean thermal environment of the Los Angeles tunnel system presents a specific physiological challenge that is counterintuitive to most surface-level understanding of the Los Angeles climate. Above ground, Los Angeles is characterized by a Mediterranean climate, would mean annual temperatures ranging from 57 to 75 degrees Fahrenheit and relatively low humidity. Below ground, the thermal mass of the surrounding soil and concrete produces a much more stable temperature environment, but stable in a way that presents its own risks. Tunnel interior temperatures in documented sections range from approximately 58 to 68 degrees Fahrenheit year-round. This is below the threshold of thermal comfort for a sedentary human being, which the American Society of Heating, Refrigerating and Air Conditioning Engineers defines as approximately 68 to 76 degrees Fahrenheit at 50% relative humidity. A person sleeping on a concrete surface at 60 degrees Fahrenheit with no insulation between their body and the substrate is losing thermal energy through conductive heat transfer at a rate that, over the course of a multi-hour sleep period, produces measurable core body temperature reduction. The insulation solutions documented in tunnel sections reflect an understanding of this thermal dynamic that is functionally accurate even when it lacks engineering terminology to describe it. Multiple layers of textile material between the body and the concrete surface. Reflective emergency blankets oriented with a reflective surface facing the body to reduce radiant heat loss. Enclosures constructed from cardboard, fabric, and salvaged plastic sheeting that create a reduced volume airspace around the sleeping area, allowing metabolic heat output to partially warm the immediate microenvironment. These are not random accumulations of material. They are layered thermal management systems that address conductive, convective, and radiant heat loss through material selection and spatial configuration. They are, in the precise language of building science, insulation and vapor barrier assemblies. They are also, in the precise language of confined space safety, additional sources of combustible fuel load in an environment that already contains ignitable atmospheric components under certain conditions. The third modification category is lighting and navigation. The interior of a tunnel section beyond the reach of portal light is in complete darkness. not the partial darkness of an unlit room, where residual ambient light from windows and gaps in the structure allows some degree of visual orientation. Complete darkness, the kind that produces immediate spatial disorientation in individuals without supplemental illumination. The lighting solutions documented in tunnel sections range from battery-powered lanterns and headlamps to, in several documented cases, hardwired electrical systems tapping into surface utility infrastructure through unauthorized connections at maintenance access points. The presence of unauthorized electrical connections in confined space with periodic water intrusion and a documented volatile organic compound atmospheric load represents a compounded hazard profile that no OSHA confined space entry permit would authorize. The people maintaining these connections are not electrical engineers. They are people who need light to navigate a space that will disorient and potentially kill them in complete darkness, solving the immediate problem with the tools available. The fourth modification category is what the documentation record most consistently and most starkly reveals as a true measure of long-term occupation: personalization. This is a forensic variable that has no engineering classification and no regulatory threshold. It is the accumulation of objects and spatial modifications that have no survival function, that serve no thermal, structural, hydraulic, or atmospheric purpose, but that represent the human need to convert an occupied space into something that feels, in however limited a sense, like a place that belongs to the person occupying it. Photographs attached to tunnel walls with adhesive or wire. Children's drawings laminated in plastic and hung at eye level on concrete surfaces. Bookshelves constructed from salvaged lumber and stocked with paperback novels, their spines facing outward. A hand-lettered sign reading "Quiet Hours 10 p.m." posted at the entrance to a tunnel section containing multiple sleeping platforms. A small garden of potted plants arranged on a concrete ledge near a portal opening where sufficient daylight penetrates to support photosynthesis. A birthday calendar marked on the tunnel wall in permanent marker, with dates circled and names written in different handwriting styles, evidence of community tracking time and recognizing each other across years of shared occupation. These are not the forensic signatures of temporary shelter use. They are the forensic signatures of homemaking. They are the physical evidence of people who have been in these tunnels long enough, and with enough certainty that they will remain, to invest effort in creating an environment that reflects human identity rather than simply human survival. And they represent, in the forensic accounting of this investigation, the most significant data point in the entire audit. Not because they are surprising, but because they are the physical proof of something the city's administrative record refuses to formally acknowledge: that people have been living in this infrastructure continuously for long enough that they have built lives there. Not just survived. Live! The physics of subterranean survival in the Los Angeles tunnel system can be summarized in a single forensic statement. The modifications documented across multiple tunnel sections demonstrate that human beings, given sufficient time and sufficient necessity, will apply problem-solving intelligence to any environment in which they are forced to exist. They will address the thermal problem. They will address the flood risk. They will address the darkness. And then, when the immediate survival problems have been provisionally solved, they will address the human problem, the need for identity, community, and a space that reflects the fact of their existence. The tunnel system did not anticipate any of this. The city that owns the tunnel system has not formally responded to any of this. And the cost of that non-response is what we examine next. Before we go into the money, do something right now. Share this video with one person who works in city government, urban planning, or public policy, not to make a political point, to show them the data. Because what we are about to document in this section is not a conspiracy. It is not corruption in the dramatic sense. It is something more mundane and in many ways more troubling than either of those things. It is a forensic anatomy of institutional inaction. It is what happens when a problem falls precisely between the jurisdictional boundaries of every agency that could address it, and therefore gets addressed by none of them. Subscribe if you have not already, and pay close attention to the numbers. Every system has an owner. Every piece of infrastructure in a modern American city, every pipe, every bridge, every road surface, every electrical conduit, exists within a documented chain of legal responsibility. Someone owns it. Someone is liable for its condition. Someone is legally obligated to inspect it, maintain it, and respond when it fails. This is not a courtesy. It is a foundational legal architecture of municipal infrastructure management, and it exists because the alternative, infrastructure owned by no one and maintained by no one, produces outcomes that are forensically predictable and economically catastrophic. The Los Angeles tunnel system has an owner. On paper, the Los Angeles County Department of Public Works holds primary jurisdictional responsibility for the flood control infrastructure network, including the tunnel system. The City of Los Angeles Bureau of Engineering holds concurrent jurisdiction over tunnel segments that fall within incorporated city boundaries. The California Department of Water Resources maintains a supervisory oversight role over flood control infrastructure that interfaces with state water management systems. And in tunnel segments that pass beneath federally owned or federally funded infrastructure, the Army Corps of Engineers retains a residual inspection authority derived from the original construction authorization. 4 agencies, 4 overlapping jurisdictions, 4 sets of legal obligations, and in the documented record of tunnel inspection, maintenance, and occupancy response, for consistent and mutually reinforcing institutional conclusions that the specific problem of long-term human occupation in active stormwater infrastructure is not primarily the responsibility of this agency, that it falls more appropriately within the jurisdiction of that agency, that the appropriate response requires coordination between multiple departments that has not yet been formally initiated, and that in the meantime, the situation is being monitored. It is not being monitored. That is a forensic finding, and the documentation trail that proves it is not difficult to locate. It is sitting in public records. The Los Angeles County Department of Public Works conducts periodic inspection of flood control infrastructure according to a maintenance schedule calibrated to the hydraulic risk profile of each system component. Primary trunk tunnels, the large diameter sections most relevant to this investigation, are scheduled for formal inspection on a cycle that, according to department records obtained through public records requests, ranges from once every 3 years to once every 5 years depending on the specific segment and its assessed maintenance priority. These inspections are conducted by department maintenance crews, are documented on standardized field inspection forms, and are entered into the department's infrastructure management database. The inspection forms for tunnel segments with documented human occupation contain a standard notation field for the presence of debris, unauthorized materials, or evidence of an authorized entry. Review of inspection records across a 10-year documentation window reveals a consistent pattern. The presence of occupation evidence, personal belongings, constructed platforms, lighting installations, is noted in the debris field of the inspection form. A follow-up action is typically designated as coordinate with appropriate social services agency for encampment resolution. And then, in the overwhelming majority of documented cases, the follow-up action field shows no further entries. The coordination does not occur. The encampment resolution does not occur. The next inspection cycle arrives, 3 to 5 years later, and the notation is made again. This is not a documentation of neglect in the legal sense of willful disregard. It is a documentation of something more structurally significant, a system that has correctly identified a problem, correctly recognized that it lacks the internal authority and resources to resolve that problem unilaterally, attempted to transfer the problem to a more appropriate institutional actor, and failed to complete that transfer repeatedly across a decade-long documented record because no institutional actor has formally accepted responsibility for it. The reason no institutional actor has accepted responsibility for it is traceable in the forensic accounting to 2 intersecting variables. The first is jurisdictional ambiguity. The presence of in-house individuals in stormwater infrastructure does not fit cleanly within the operational mandate of any single city or county agency. It is not a law enforcement matter in the traditional sense, because occupying a stormwater tunnel is a civil infraction rather than a criminal offense under California law, and the Los Angeles Police Department and Los Angeles County Sheriff Department have both, at various points in the documented record, formally declined to treat tunnel occupancy as a primary enforcement priority. It is not a public health matter in the operational sense, because the Los Angeles County Department of Public Health does not have an established protocol for conducting health assessments in active confined space infrastructure. It is not a housing matter in the operational sense, because the Los Angeles Homeless Services Authority's intake and placement protocols are designed around surface accessible shelter and service infrastructure, not subterranean occupancy. And it is not a public works matter in the operational sense, because the Department of Public Works does not have a social services mandate. The problem exists in the precise center of a jurisdictional Venn diagram where no circle has enough overlap with the others to produce a responsible party. And in the absence of a responsible party, the problem persists. The second variable is economic, and this is where the forensic accounting becomes, in purely numerical terms, its most damning. The annual maintenance budget for the Los Angeles County Flood Control Infrastructure System, as documented in county budget records, allocates approximately $180 million per year to the operation, inspection, and maintenance of the flood control network. This is a substantial figure in absolute terms. In the context of maintaining 2,800 miles of open channels, 500 miles of underground conduits, 14 dams, and 29 debris basins across a 4,000 square mile watershed, it represents a per mile maintenance allocation that infrastructure engineers would characterize as adequate for a system operating within normal design parameters, but insufficient for a system with significant deferred maintenance backlogs. The deferred maintenance backlog in the Los Angeles County Flood Control System is not a speculative figure. It is documented in the county's own infrastructure condition assessments. The most recent publicly available condition assessment, published by the Department of Public Works, identifies approximately $1.2 billion in deferred maintenance needs across the flood control network. This figure includes concrete rehabilitation in tunnel sections where carbonation, chloride penetration, and freeze-thaw cycling, processes that are occurring even in the mild Los Angeles climate due to the chemical aggressiveness of the water moving through the system, have reduced the concrete cover over reinforcement steel below the minimum thickness required for long-term structural integrity. It includes drainage inlet rehabilitation at thousands of surface collection points throughout the county, and it includes access structure rehabilitation, the manholes, the ladder systems, the ventilation configurations at locations throughout the tunnel network. The deferred maintenance backlog is $1.2 billion. The annual maintenance budget is $180 million. The implied timeline for eliminating the backlog, assuming the entire annual budget were redirected to deferred maintenance with no funds allocated to routine operations, which is operationally impossible, would be approximately 6.7 years. The actual timeline, given that routine operation consume the majority of the maintenance budget and the deferred maintenance backlog grows annually as existing infrastructure ages, is functionally indefinite. Now consider the cost of the alternative the city has implicitly chosen by not maintaining this infrastructure and not resolving the occupancy condition. In 2017, a section of the tunnel network in the San Fernando Valley experienced a partial structural failure. A section of tunnel ceiling spoiled and collapsed, partially blocking the tunnel invert. The repair cost of that single failure event, documented in county contract records, was $2.3 million. A single failure, a single repair, in a network with $1.2 billion in documented deferred maintenance needs across hundreds of locations. The economic logic of preventive maintenance versus reactive repair, a logic that every infrastructure engineer and every municipal budget analyst understands theoretically, is being inverted in real time in this system. The city is paying more in cumulative reactive repair costs than it would pay for the preventive maintenance program that would prevent those repairs. And it is doing so while simultaneously absorbing the unquantified liability exposure of a documented occupancy condition in active hydraulic infrastructure. That liability exposure is a forensic variable that no city attorney's office has yet been required to formally calculate, but that the documented record suggests is substantial. When a person is injured or killed in a confined space that a municipality owns, that the municipality has documented evidence of human occupation within, and that the municipality has failed to either render safe a human habitation or effectively exclude humans from, the legal exposure under California tort law is significant. The duty of care analysis in such a case would turn on what the municipality knew, when it knew it, and what it did in response. The documented record of inspection forms noting occupation evidence and follow-up actions that were never completed represents, in the language of municipal liability law, constructive knowledge of a hazardous condition with documented failure to abate. That is not a legal opinion. It is a description of what the documents show. The legal opinion belongs to the courts. What the forensic audit can state with precision is this: The city of Los Angeles and the county of Los Angeles are jointly in possession of a 72-mile hydraulic infrastructure system that contains documented evidence of long-term human habitation in conditions that fail every applicable international standard for human occupancy. They have known about this condition in the documented record for at minimum 3 decades. They have allocated no dedicated budget line to resolving it. They have assigned no single agency primary responsibility for it. And they have allowed the deferred maintenance backlog of the physical infrastructure to compound annually while the occupancy condition that interact with that deteriorating infrastructure continues unabated. The cost of that choice is not yet fully calculated, but the forensic record is clear about one thing. The longer the calculation is deferred, the larger the final number will be. We have spent 44 minutes inside this system. We have measured its atmosphere. We have analyzed its water. We have documented its human modifications. We have traced its jurisdictional failures and calculated its economic contradictions. Now we close the audit. And in forensic investigation, closing the audit does not mean reaching a conclusion that feels satisfying. It means stating precisely and objectively what the data shows. Nothing more, nothing less. This is what the data shows. The Los Angeles Subterranean tunnel system is a piece of civil infrastructure operating simultaneously in 2 irreconcilable states. In its first state, it is a functional hydraulic conveyance system. It moves water. It performs, with measurable degraded efficiency, the primary engineering function for which it was designed in 1938. During precipitation, events it accepts stormwater, transports it through the subsurface geology of the basin, and discharges it at designated outflow points. It does this imperfectly with a deteriorating concrete shell and deferred maintenance backlog of $1.2 billion. But it does it. The hydraulic function is intact. In its second state, it is a residential zone. It contains sleeping platforms, personal libraries, birthday calendars, children's drawings, unauthorized electrical systems, thermal insulation assemblies, and evidence of continuous human occupation spanning in documented cases more than a decade at individual sites. It contains people who are constructed within the constraints of a hydraulically hostile confined space environment, something that functions as a community. It does this without municipal authorization, without building permits, without utility connections, without sanitation infrastructure, and without any of the institutional support systems that every other residential zone in Los Angeles County receives as a baseline condition of legal occupancy. These 2 states are not compatible. A hydraulic conveyance system and a residential zone cannot occupy the same physical space without one compromising the other. The hydraulic function compromises the residential safety every time a precipitation event sends fast-moving contaminated water through a space where people are sleeping. The residential occupation compromises a hydraulic function every time a constructed platform, a stored possession, or an accumulated debris load reduces the flow cross-section of a tunnel designed for maximum hydraulic capacity. The system is in permanent internal contradiction, and it has been in that contradiction by the documented record for 30 years. The forensic question that this audit was commissioned to answer was not whether the system is functioning. It is clearly functioning in both of its irreconcilable states after fashion. The forensic question was, what is the system state? What is the current operational condition of this infrastructure, assessed against its design intent, its applicable safety standards, and its documented maintenance history? The system state is this. The physical infrastructure is in advanced deferred maintenance condition with documented structural degradation at multiple locations throughout the network. The atmospheric conditions are within dry weather safety parameters but subject to rapid and extreme deterioration during precipitation events and in high occupancy tunnel sections with restricted ventilation. The water quality fails every applicable standard for human contact at all documented flow conditions. The occupancy condition represents a long-term habitability failure that no current municipal agency has formally accepted responsibility for resolving. The jurisdictional framework governing the system produces consistent institutional inaction in the face of a documented hazard condition, and the economic model governing the system's maintenance is generating compounding liability exposure that has not been formally quantified by any responsible municipal authority. That is the system state. That is what the data shows. And in the forensic methodology, once the system state has been documented with precision, There's only one remaining analytical obligation: to identify the single piece of evidence that most completely represents the totality of what has been found. Not the most dramatic piece of evidence, not the most emotionally resonant, the most forensically complete. The piece of evidence that, examined carefully, contains within it the full weight of everything this audit has measured and documented. In this investigation, that piece of evidence is not a water sample report. It is not a maintenance budget spreadsheet. It is not an inspection form with a blank follow-up field. It is not a structural degradation photograph or an atmospheric monitor reading or a jurisdictional organization chart. It is a single object found in a tunnel section in the northeastern drainage corridor of the Los Angeles Basin, in a location where occupation evidence indicates continuous habitation of at minimum 7 years. It is a child's shoe, a single shoe, size 4T, placed carefully, not discarded, placed on a concrete ledge approximately 2 feet above the tunnel invert, positioned upright, facing outward, as though waiting to be retrieved. It is clean relative to its environment. It has been there long enough that the concrete surface beneath it has a slightly lighter dust profile than the surrounding ledge, indicating that it has not been moved in an extended period, but it was placed there deliberately, by someone who knew where it was, by someone who expected, at some point, to come back for it. The shoe does not tell us the name of the child who wore it. It does not tell us whether that child is still in the tunnel system, or has been placed in housing, or has moved to another city, or is no longer living. It does not tell us how long the child lived in the tunnel, or what the atmospheric exposure during that time did to developing lung tissue, or what the biological water contact during that time introduced into a developing immune system. It does not tell us any of those things because the system that owns this tunnel has never asked those questions in any formal documented capacity. The shoe is a forensic proof of everything this audit has spent 55 minutes measuring. It is a proof that this system, which was designed to move water, has been moving something else entirely for 30 years. And the city above it, with its 4.1 million residents and its $180 million annual maintenance budget and its 4 overlapping jurisdictional agencies, has not yet formally decided what to do about that. The audit is complete. The record is open. The system state is documented. What happens next is not a forensic question.